Hi everyone, my name is Shreya Jairam and this is my video for experiment 3 on circuits for physics 2212. Introduction. The purpose of this experiment is to model a circuit in order to test the behavior of a circuit when different scenarios are introduced. The fundamental principles utilized in this experiment were conservation of energy, node rule, loop rule, Ohm's law, capacitance, and the time constant of RC circuits. The main result of this lab showed the modeled circuit behaved as expected by the various fundamental principles listed above. The assumptions made in this experiment were that the resistance of the wires and ammeters were negligible and that the EMF was equal to the delta V of the capacitor plus delta V of the resistors. So models. So first, a conservation of energy means that energy cannot be created or destroyed. The node rule says that the current in is equal to the current out of the node. The loop rule says that the sum of the potential difference is equal to 0. Ohm's law says that V is equal to IR. Capacitance says that C is equal to Q divided by V. And the time constant says that the natural log of the potential difference at a point divided by the original potential difference is equal to negative T over RC. So experiment part 1. The system was a circuit and the surroundings for everything else. My prediction was that the current would be 0.02 amps, which was correct. When the ammeter was connected backwards, the reading stayed the same in my case. And when a voltmeter replaced an ammeter, the reading was 3 volts because it read the potential, and the ammeter read 0 amps because the circuit was open. The sum of the potential differences across the circuit was 0, which follows the loop rule. As you can see here, the potential difference from B to A was 3, from D to C was negative 0.96, and F to E was negative 2.04, and when all three of these are added together, it's equal to 0. And the voltmeter does not change the reading of the ammeter because it essentially has no current flowing through it. And when connected in parallel with the resistor, the ammeter read 0.06 amps, and the resistance of the first resistor was calculated to be 48 ohms, and the second resistor was 102 ohms, which is very close to the set values, which were 47 ohms and 100 ohms, and this error can be attributed to the resistance of the wires and ammeter being negligible. And the wire and ammeter both had 0 ohms of resistance as calculated from this. And here, this graph shows the approximate graph of the potential difference over these points. As you can see, it goes down at the 47 ohm resistor, stays the same here, goes down to 0 here, and then stays at 0 as predicted by this chart. So experiment part 2. The system was a circuit and the surroundings were everything else. When the battery was connected, the light started bright but became dimmer as the capacitor charged, and the current started at 0.9 amps and went down to 0 amps. When the current circuit was just the light and the capacitor, the light started bright but became dimmer as the capacitor discharged, and the current started at the max and went down to 0 amps as it charged. Or discharged. With the 10 ohm resistor, it took 14.94 seconds to charge and 15.4 seconds to discharge. And with the 20 ohm resistor, it took 27.85 seconds to charge and 27.69 seconds to discharge. And for the circuit with the 30 ohm resistor, the calculated RC value was 5.988, which agrees with the predicted RC value of 6. And as you can see here, as said before, the RC constant can be calculated by dividing time. So it would be 1 over this value is equal to time. So when you divide 1 by this value, you get the RC constant, which is how this was calculated. So discussion. Since the virtual simulator modeled an ideal circuit, there was likely no points for error within the experiment itself, but some can be attributed to data collection, such as the time data not being perfectly accurate, which is human error. For the first what if question, if this experiment was done with a real ammeter, errors from the ammeter could have some amount of resistance, or it could not be perfectly ideal, which would have attributed to a discrepancy in the readings found. And for the second what if question, if the experiment was done using a real battery, it likely would have taken more time to charge the capacitor, since a real battery might not have the full voltage it is supposed to. In conclusion, this virtual simulator modeled an ideal circuit and performed in agreement with fundamental laws and principles, such as the node rule and the loop rule. I was able to determine the charge and resistance of items in a circuit, as well as the time constant in a circuit involving a capacitor. Thank you.